Okay, let's think about our solar system for a minute. Not now, not billions of years ago, but way out in the future. Billions of years from now.
Right, a very different picture.
Yeah, imagine our sun. Not the yellow star we know, but huge, red, swollen. That's what we're diving into today. The sun becoming a red giant.
It's a pretty dramatic transformation. The source material you sent over really digs into how this stellar change is going to reshape, well, everything, including where life might possibly exist later on.
Exactly. And that's our mission for this deep dive, using these sources, trying to get a handle on how this completely redefines habitability right here. It kind of challenges what you might expect. We're looking beyond Earth, out to the outer planets, their moons, places that are deep frozen right now.
It sounds totally backwards, I know, but the sources explore this idea that these icy worlds could, maybe just for a short time, actually become potential spots for life.
Okay, yeah, let's unpack that. So this whole journey kicks off in about, 5 billion years?
Around then, yeah. That's roughly when the sun burns through the hydrogen fuel in its core.
And that's the end of its stable phase.
Pretty much.
Yeah.
It leaves what we call the main sequence, that long period where it's just steadily fusing hydrogen. Once that core fusion stops, gravity kind of wins for a bit, the core shrinks, heats up, and then hydrogen fusion restarts, but in a shell around the core.
Okay.
And that process pumps out a ton of energy, causing the outer layers to just balloon outwards massively. That's your red giant.
Right. And that ballooning, that spells trouble for the inner planets, doesn't it?
Or absolutely. Immediate destructive consequences. Mercury, Venus, probably scorched, maybe even swallowed whole. Earth's surface. Habitability becomes extremely unlikely, probably impossible.
So the inner solar system basically becomes uninhabitable.
Pretty much. But while that's happening, all that extra energy pouring out drastically changes where the habitable zone is located.
The zone where liquid water could exist.
Exactly. As the sun gets bigger and brighter, that zone migrates way, way out. The source material suggests it could shift from where it is now, around Earth's orbit 1 AU, out to maybe 5 or 6 AU.
5 to 6 AU? Wait, that's out by Jupiter? Jupiter and its moons are in that range?
It is, yeah. So this shift means the gas giant, its moons, places that get hardly any warmth now, they'll start receiving enough solar energy to actually warm up their surfaces, their atmospheres.
Wow.
And the source material, it poses some fascinating questions for you, doesn't it? Like, could Mars briefly become more temperate? Could Europa, Jupiter's moon with that huge ocean under the ice, could it go from being this frozen ball to something potentially steamy, a haven?
That really drives home that point from the source. Habitability isn't like a fixed spot. It moves. It's dynamic.
It really is. And Europa is flagged as, a prime candidate for this kind of change. We know it has that massive ocean under kilometers of ice today. But the source suggests that during the peak red giant phase, maybe around 12.5 billion years from now, the intense sunlight, plus maybe extra light reflecting off a brighter Jupiter, could cause Europa's surface ice to sublimate.
Sublimate, you mean like dry ice? Just poof, straight from solid ice to water vapor, skipping liquid on the surface.
Exactly that, turning straight into gas.
Yeah.
It's kind of wild to picture happening on a moon.
Yeah, it really is.
And this sublimation, this process, it could maybe form a temporary atmosphere of water vapor around Europa.
Yeah.
But here's the kicker, something the source really emphasizes, challenging our usual ideas.
Okay.
This potential habitable window. It's not long. The estimates are maybe on the order of 105 to 106 years, so tens of thousands, perhaps up to 1 million years.
1 million years, that sounds like forever to us, but geologically, evolutionarily, that's incredibly fast, a blip.
It is. A cosmic eye blink, really.
So the source asks, right, could life, maybe microbial life, already hiding in that subsurface ocean, actually emerge or adapt to that fleeting surface condition in such a short time? That seems like a huge ask, given how long complex life took here.
It's a massive challenge. And the source material really pushes us on this, It makes you question how long conditions really need to be stable for life to get a foothold, or just adapt if it's already there. It doesn't say how, but it forces the question. Is life maybe more adaptable or emergence faster than we usually think? Even just microbes grabbing a short opportunity.
Huh.
And it's not just Europa feeling the heat. Jupiter itself is going to react pretty significantly to all that extra solar radiation.
Is the whole giant planet going to change?
Well, the source suggests its upper cloud layers could change. Maybe transition to bright water cloud decks as it warms up.
Water clouds on Jupiter?
Potentially.
Yeah.
And that would make Jupiter much more reflective, increase its albedo, which could bounce even more warmth onto nearby moons like Europa. Some models even suggest Jupiter might sort of puff up a tiny bit.
Like expand slightly.
Yeah, though its huge gravity would likely stop any major expansions. It's not going to turn into a different kind of planet or anything.
Kind of like trying to inflate a bowling ball.
Something like that analogy, yeah.
Yeah.
But the source does point out potential stresses. Changes inside Jupiter could maybe tweak the tidal forces squeezing Europa. Those forces are crucial for keeping its ocean liquid.
Ah, right. The tidal heating.
Exactly. And then you've got these intense stellar winds from the giant sun. How they interact with Jupiter could even affect Europa's orbit, potentially its stability. The source is basically asking, just how tough is the Jovian system when faced with this kind of onslaught?
So researchers are trying to model all this, figure out the nuts and bolts.
They are. The source mentions looking at two main phases when the red giant habitable zone reaches Jupiter.
Okay.
Scenario 1 is maybe 12 billion years from now. The sun's atmosphere reaches out about 2 AU, and Europa, in its orbit around Jupiter, dips into this new habitable zone sometimes.
And scenario 2.
That's a bit later, maybe 12.5 billion years. The sun expands even more, potentially pushing Jupiter's orbit closer, maybe even inside the sun's really thin outer atmosphere, the stellar envelope.
Whoa, inside the sun's atmosphere. That sounds intense.
Yeah, potentially. According to some models in the source, that would mean much stronger interactions with the stellar wind, radiation, everything. These simulations are trying to track it. All sunlight increase, orbital shifts, how well planets or moons hold on to any atmosphere they might get.
And for Europa, that temporary atmosphere.
Right. The source notes that even with all that sublimation, Europa's low gravity means it would likely lose most of that water vapor to space pretty fast. But maybe enough could stick around for that thin temporary atmosphere we talked about, that million-year window, perhaps.
Understanding this stuff, this really specific future for our system, it must have pretty big implications for how we look for life out there, beyond our sun.
Right. Oh, absolutely. Our solar system's future is like a vital test case, a blueprint for studying exoplanets. Think about what this tells you when we point our telescopes outwards.
How so?
Well, something like, over 90% of the exoplanets we know orbit stars that are also going to end up as white dwarfs eventually. Those are the dense remnants left after the red giant phase blows off its outer layers.
So watching our own sun's endgame is kind of like seeing a preview for most other star systems.
In a sense, yeah, especially those early dramatic stages. And what's really interesting, as the source highlights, is that we see some white dwarfs that have these water-rich debris disks around them.
Debris disks, like leftover bits.
Exactly. And the sources connect this back to our system. They hint that maybe these disks are the pulverized remains of exomoons or asteroids that actually survived the red giant violence.
Ah, okay. So bits of former Europas or Ceres, maybe?
Potentially. And if you connect that to the bigger picture, the red giant phase is brief, it's violent. But white dwarfs, they just fade out incredibly slowly over cosmic time. So their habitable zones, which are much closer in, could potentially offer really stable long-term homes for life, very different from the quick pulse during the red giant phase.
That's a really interesting contrast, a long, slow-burn habitat around a white dwarf versus this brief, dramatic flash of potential around the dying red giant. What kind of life could even exist there, or what would we look for?
That's a key question, and one the source material really prompts you to think about. What sort of unusual chemistries, what kind of biosignatures would future telescopes like the Roman Space Telescope mention need to be sensitive enough to find in these, old stellar graveyards? Could life adapt to totally different energy sources, different timescales?
It's quite something, thinking about our own system, that life's sheer persistence, even just microbial life, might let it hang on, or even get a brief second chance on a world like Europa, precisely while our star is in its death throes.
It really does stretch our definition of habitability way beyond the sort of Earth-centric view we usually have. But that critical question the source material keeps coming back to, it's still there, and it's one for you to mull over. Can life realistically originate or even just adapt significantly in that relatively tiny window, maybe just millions of years, that the red giant phase offers on a world like Europa? Or any similar world out there?
Yeah, exploring these, really far future possibilities for our own home system.
Yeah.
It's not just about knowing what happens eventually. It fundamentally broadens our search for life everywhere, right? By forcing us to reconsider what makes a world habitable and challenging our whole notion of time.
Which leads to this important question, doesn't it? If life could exist, but only temporarily, maybe for just a million years or so, flickering into existence on a moon as its star is dying.
Yeah.
What does that possibility tell us about, the very nature of life and time across the universe?